All right, welcome back, people. Hope you guys had a good break. Enjoyed the holidays with your families. We're getting back into some trig and review. So, just a refresher. If you want to fast forward through this, feel free to pick up where we left off in class. But for number one, we're trying to find the sides of an acute triangle. So remember, the Pythagorean theorem will identify whether a triangle is a right triangle. So if a squared plus b squared is equal to c squared, that means that it is a right triangle. However, if a squared plus b squared, that's not great, is bigger than c squared, that makes it acute. All right. And if c squared is bigger than a squared plus b squared, then this is going to be obtuse. All right. So if they're equal, it's a right triangle. All right. If the a squared side is bigger, it's acute. And if c squared is bigger, it's obtuse. So if we look at number 3, we're obviously going to pick the biggest side for c squared. So 5.5 squared. We want to know, how does that relate to when I do a and b, when I do 3.5 squared plus 4.5 squared. And so if we get our calculator here, okay, we can just figure that out real quick. So 3.5 squared plus 4.5 squared, all right, is 32.5, and 5.5 squared is 30.25, so therefore 30.25, man, this pen's not doing great today. 30.25 is not as big, it's smaller than, all right, 32.5. And so this is acute because the a squared side is bigger. All right, so for the second one, all we're doing is the ratios of the sides. So we're going to do, we'll do the u's first. So when we're trying to figure out the ratios, remember ratios is just a fancy word for fraction, okay? So when I'm doing this one, I want to identify that u side, this 12 is opposite, the 10 is adjacent, and the 13 is the hypotenuse. So the sine of u, if we remember our Sohcahtoa, okay, we can figure out that so is SOH, and so the opposite would be 12 over 13. All right, the tangent of u is opposite over adjacent, right, which is going to be 12 over 10. The cosine of u is adjacent over the hypotenuse, and so this is equal to 10 over 13, and then we can fill in the other ones. Now when we switch to angle P, the opposite switches, the adjacent becomes the opposite from u, right? So 10 becomes the opposite, 12 becomes the adjacent. So what happens is that the sine of u actually be the same as the cosine of P. These are the same things because the opposite and adjacent have changed. So the opposite of u is the adjacent of P. And the sine of P is the same as the cosine of u. So this is 10 over 13. And the tangent of P is the reciprocal of the tangent of u. And so this becomes 10 over 12. So in the accompanying diagram, now we're doing the same type of question, except now it's a little tweaked. So I want to figure out AB. So if BC is 12, and I'm trying to find the length of AB, using this 40-degree angle, I would have to use opposite adjacent tangent. So the tangent of 40 would equal x over 12, but it doesn't actually, that's not one of the answers. So what I have to do is actually use this angle. But I can actually say to myself, I'm not using the hypotenuse, So I can't be using these three. But if we did do the tangent of the other acute angle, right, this becomes 12 over x, and this would be an appropriate solution then. The same thing with number 4, okay? If I'm using angle A and BC is opposite, AB is hypotenuse, and AC is the adjacent, then the sine of A is going to be A over C. The cosine of A is going to be B over C. And the tangent of A, right, is going to be A over C. So if I use these ratios, right, the sine of A, there's no way to get B sine A, okay, because there's a C in here. And if I cross multiply, I'm actually going to get C times the sine of A, which is choice 4. If I look at cosine and I cross multiply, I should get C times the cosine of A, right, is equal to B, but this says A. So that's out. And the last one would be tangent of A, which is going to be C times the tangent of A, and that should equal A. Oh, wait, it's A over B. Come on, people, worry on that one. So this should be A over B. So it'd be B tangent A, but it says C, so that one's out. So I know I'm choosing choice 4 because it's the only one that has those letters involved there. For number 5, we're going to want to draw a triangle. Okay, so there's a right triangle. Okay, it says the measure of angle ABC, so that's B, we're 90 degrees. And I'll just call these two sides A and C. It doesn't matter which one gets the A and which one gets the C. AC is 29, AB is 17. And we're looking for the measure of angle BAC, which means angle A. So remember, there's two options here, really, right? There's Sohcahtoa or there's Pythagorean Theorem. So what conditions do you need for each one, right? For Pythagorean Theorem, it's just side lengths. For Sohcahtoa, we have an angle involved. So for 5a, we can't use Pythagorean Theorem because we're talking about angle A. So when I do Sohcahtoa, steps are find the angle, label the sides. So this is my adjacent, 29 is my hypotenuse. That identifies the trig function as ca. So the cosine of my angle is the adjacent leg over the hypotenuse, and then I can plug in the cosine of A is equal to 17 over 29, and then to solve this, we have to use the inverse. So it's either going to be cross multiply or use the inverse. I cross multiply when it's a side, and I inverse when it's an angle. So by inversing, I'm going to take the cosine inverse of both sides. So the cosine inverse of cosine A leaves me with A, and the cosine inverse of this fraction is going to be my answer. So I take my calculator, do trig, cosine inverse, and then 17 divided by 29, it gives me 54. So the measure of angle A is equal to 54 degrees. Now, the length of BC, which is down here, now I could use Pythagorean Theorem because it's just side lengths. So remember the formula we talked about we could use is that B squared is equal to C squared minus A squared, and then I can just plug in. So 29 squared minus 17 squared, and this is 552. And then I'm going to square root, and B is equal to, and really we can just do 29 squared minus 17 squared is 552, square root that number. And because the next number after the 3 is a 4, doesn't matter what any other numbers are, If I'm rounding to the third spot, I only look at the mean number that immediately follows. So since it's 4 or lower, I keep it, and the answer here is 23 inches. All right. On to the next page. So just figure out x to the nearest foot. Once again, right triangle. I'm going to use Sohcahtoa because there's an angle involved, okay, not just side lengths. So from the starters, we have to identify if we're using sine, cosine, or tangent. So we label our side lengths first, okay, Sohcahtoa. So there's adjacent, there's my hypotenuse. I'm not using the opposite side, okay? So I know I'm going to use cosine. So cosine of the angle is equal to the adjacent leg over the hypotenuse. When I plug in, cosine of 40 is equal to 14 over x. And this is where it gets a little bit an extra step involved. Because when I cross multiply, since I'm looking for a side, I get x times cosine of 40 is equal to 14. So this isn't done yet because I still don't have x by itself. So I have to divide out by the cosine of 40. And this leaves me with my answer. So and then we just take our calculator, 14 divided by trig cosine 40, and we get 18 to the nearest feet. All right. For number 7, we have the ladder resting against a wall, and it's also touching the top of the fence here. So we want to do two things. We want to figure out the angle the ladder forms with the ground, which is this angle right here, okay? All right. And I also, in part B, want to determine how far up the wall, let's say this height, that this reaches. So the first thing I need to do is look at it and see that like there's actually two triangles here, right? There's this bigger triangle with the ladder, and there's this triangle with the fence. And so if I'm looking for this angle, we can say it's x for now, I have to use the small triangle first. Because the big triangle, right, only has one side length. So I have two unknowns in this one. So I can't use it yet because I have x, right? I have x, I have 15, and I have h. So I have this x here, this 15, and this h. So I need to figure out x first in the small triangle, and then I can figure out what h is. So same thing, since I'm looking for an angle, I know we're going to be doing Sohcahtoa. So 4 is my adjacent side, 6 is the opposite side, and so this is going to be a tangent, opposite over adjacent. So tangent of the angle is the opposite leg over the adjacent leg. And then we're going to plug in. So the tangent of x is equal to 6 over 4. And now, because we're looking for an angle and I want to get rid of the tangent, I'm going to take the tangent inverse, right, of both sides. So the tangent inverse of the tangent of x, peace out, is equal to the tangent inverse of 6 over 4. So x is equal to, take my calculator, trig, tangent inverse 6 over 4, and I get 56 degrees to the nearest degree. All right, the second part is now to figure out the height. So now that I know that this angle is 56, now we can do it. Because once I have an angle measure, I know I can use Sohcahtoa again. So with the given figures, I'm not using the adjacent side. So I know that I'm going to use sine, right? So sine of my angle, come on now, sine angle is the opposite leg over the hypotenuse. All right, so sine of 56 The opposite is h. The hypotenuse is 15. And then we cross multiply. So h times 1. And then 15 times the sine of 56. And there's 12.435, or nearest foot, and there's 12 feet. All right, so for number 8, we have a rectangular block of wood leaning against a wall. We have a few pieces of information. We know that this side AB is 8. We know that side BC is 5. And I know that this degree measure of angle BAE is 28 degrees. Now I also know that this triangle is a right triangle. So that means if this angle is 28, right, then 90 minus 28 tells me this is 52 degrees. Nope, 62. Okay, for this angle. And since this is a rectangle, there's a right angle there. And in this triangle, if these three add to 180, then, or if this is 90 and this has to be 90, that makes this angle also 28 degrees. So we need the measure of that angle because I have to be able to figure out two things. If I want to determine the height from C to the ground, that line is actually the same as this. So really, I just need to figure out the length of FE. So if I can figure out FB and BE, then I can just add them together. So that's the strategy here. All right, so let's do BE first. So BE, we'll do that side first. All right, so same concept. I'm looking for, let's say, X here. Okay, so this is the opposite leg. There's my right angle. So this is the hypotenuse and adjacent. I'm not using the adjacent. So we're going to do the sine of 28 is equal to X over 8. And then when I cross multiply, 8 times the sine of 28 is equal to X. We're not going to round this yet. So 8 sine 28, and I get that crazy number right there. We're just going to hold on to that, okay? On the same token, we're looking for FB. And so in this triangle, right, from this 28-degree angle right here, we'll call this Y. So this side is adjacent, FC is the hypotenuse, or opposite, and phi is my hypotenuse. So I'm not using the opposite. So this is going to be the cosine of 28 is equal to Y over 5. And then when I cross multiply, 5 times the cosine of 28 is equal to Y. Hold on to that first number, okay? So 5 cosine 28 is 4.41, okay? And we know the first number was 3.75. We want to go to the nearest tenth. So we don't always want to round both of them and then add them together because we could end up with being off at the end. So what we really want to do is we really want to add those together, okay? So FE, and to be exact, is really going to be 8 sine 28 plus 5 cosine 28. And so if I use those numbers, we should be good now. Now, technically, if we rounded, we get 3.8 and 4.4. So 3.8, right after the 7 comes 8, after is a 5, so pushes 8, plus 4.4, we get 8.2. Now, if we take our two answers, right, up arrow and highlight, I can grab them. I'm still going to get 8.2. But there could be an instance where this might be a little bit lower, and if I round them together, it actually is off. So just be careful. So we want to add together the exact numbers and then round them. And so we end up with an answer of 8.2, and then this would be centimeters. All right, in the accompanying diagram, a flagpole stands on level ground. Two cables R and S are attached to the pole 16 feet above the ground. The two cables, okay, so we know that R plus S has to equal 50. All right, cable R is attached to the ground 12 feet from the base of the pole. What is the measure of X to the nearest degree? All right, so a couple things, right? So we need to figure out R or X. To get that, we actually need S, right? Because if I'm looking at this triangle, if I have S, I can do some Sohcahtoa action here. So since R plus S is 50, if I actually can figure out R, right, then I can tell you what S is, and we can go from there. To get R, since I'm talking about side lengths, we can just do some Pythagorean theorem. So a squared plus b squared is equal to c squared. Now, for a and b, we can just plug in 16 and 12. It doesn't matter if a is 12 and b is 16, since we're adding them together. The order doesn't necessarily matter. And 16 squared plus 12 squared is 400. And then the square root of 400 is going to be 20. And so if R is 20, and they both add to 50, that makes S 30. So now, in the blue triangle, if I'm using X, okay, 16 is the opposite, and 30, which is the side, is my hypotenuse. So we're going to bust out our Sohcahtoa here. And since we're using opposite and a hypotenuse, we're going to use sine. So the sine of my angle is the opposite leg over the hypotenuse. And then we plug in the sine of x. The opposite is 16. The hypotenuse is 30. And since we're looking for an angle, we really need to get rid of the sine. So we're going to bust out our sine inverse. So the sine inverse of the sine of x, those two cancel out, is the sine inverse of 16 over 30. And x is going to be to the nearest degree. So trig sine inverse 16 divided by 30. Nearest degree is going to be 32 degrees. All right. Andrew is at a park. A deer is 3 kilometers directly north of Andrew at point D. All right, we're going to go Andrew. So 3 kilometers directly north. Boom. Point D for deer. And Brian is standing 1.8 kilometers west. Boom, that's left. Remember west and east. Okay. There's a diagram. Calculate distance between the Brian and the deer. So here's B Ryan. And if we do this, okay, since we're going north and west, that makes a right triangle. And so since we're talking about sides, we're just going to do some good old Pythagorean theorem here. Now, I'm going to plug in 3 for A, 1.8 for B. It doesn't matter if you switch those. That's 12.24. And then we'll square root that answer. All right. And to the nearest kilometer, that's going to be 3. Now, if Brian looks at Andrew, then turns through an angle to look at the deer, that means that Brian is looking this way, and then he looks up to the deer. So theta is this angle right there. Calculate the value of theta to the nearest degree. So we're going to use the 3 for we're going to use the original measurements for this, okay? The original measurements. So essentially, we have a right triangle with 1.8 and 3 theta here. We're going to use the original, so we're not going to use this side, okay? We're not going to use our hypotenuse. All right, so we are not using this. So we're going to use some tangent action. So tangent of the angle is opposite over adjacent. And remember, once again, 3 is the opposite. It's across from the angle. 1.8 is the adjacent. So tangent of theta is equal to 3 over 1.8. And because it's an angle and I want to get rid of tangent, I have to use the tangent inverse to both sides. Okay. So the tangent inverse of tangent theta leaves me with theta. What is that thing? I'm building a snowman over here. Theta, there we go. All right, is equal to the tangent inverse of my fraction, 3 over 1.8. Tangent inverse. And I'm going to get 59 degrees. All right. Number 11 on the next page. We have a trapezoid prism here. So on this front face, right, we have a height of 3 kilometers. We know that the length of DC down here between the two triangles is 7. All right. The vertical height from A on the top of the roof down is 3. So we want to figure out the length of AD first, the nearest 100, this side right here. So if I'm focusing on this triangle, that's my hypotenuse. Okay. And since I'm using an angle, I'm going to use some Sohcahtoa. So if I'm using opposite and hypotenuse, that is sine. So sine of my angle is the opposite leg over the hypotenuse. So the sine of 55 is equal to 3 over, we'll call it x. And then I'm going to cross multiply. So x times the sine of 55 is equal to 3. And remember, the last step is to get rid of that sine of 55 from both sides. So we're going to divide it out. We'll get rid of it from the x. All right. And then we take our calculator. 3 divided by the sine of 55 is 3.623. We're going to nearest hundredth, so that's 3.66. All right, and this is in meters. And the last thing we want to do is calculate the length of the diagonal from D to B. So now we're using this triangle, and because it's a rectangle, if this side is 7, so is this one. All right, now we're in meters, so 7 meters. And then we're looking for the hypotenuse. So we already know this side is 3.66. So we're going to bust out with some Pythagorean theorem here because we're talking about side lengths. So 3.66 squared plus 7 squared is equal to c squared. All right, and that's 62.3956. 62.3956. And then we're going to square root. And I get that guy. So to the nearest hundredth again is 7.899. So that's 7.90. And there's the length of DB. All right, 12. A ladder is standing on horizontal ground leaning against a vertical wall. All right. You have a wall, right? Wall. That's terrible. Don't do that. I'm just going to draw simple, right? There's my wall, okay? My ladder. My ladder is kicking out this way. All right. And the distance between the bottom of the ladder and the base of the wall, so that's this side down here, okay, is 2.2 meters. I'm going to try to draw a little bit better. 2.2 meters. All right. The length of the ladder is 4.5 meters. All right. So sketch it. Boom. Calculate distance between the top of the ladder and the base of the wall. So that's actually this side right here. So once again, we're only talking about side lengths. So that's going to be some Pythagorean theorem. Now, because I'm looking for a leg, I'm actually going to use this formula. A squared is equal to c squared minus b squared. But you can still use your original. Okay, so this is really x squared, and then 4.5 squared minus 2.2 squared. Now I can't subtract those two things. I have to square them out first. Remember, order of operations, parentheses first. Double check 2.2, and that gives me 15.41. So x squared is equal to 15.41. All right, and then I'm going to bust out my square roots. And I get that one, and we're going to the nearest meter, so that would be approximately 4 meters. So the squiggly there means approximately, and there's my answer. And for C, we want to know the obtuse angle made by the ladder with the ground. We want to know what's the measure of the angle of the ladder with the ground right there. So if I use the original sides, this is adjacent and hypotenuse. So I'm going to do some cosine action here. Okay, so once again, there's my ladder, there's the wall, 2.2, 4.5, pausing for announcements. All right, there's our Bill's Day announcement. So we're trying to figure out this angle. We can call that y. So once again, we have adjacent and hypotenuse. So we're going to use some cosine of the angle is equal to the adjacent side. So that's 2.2 over the hypotenuse, 4.5. So remember our formula, cosine of my angle, adjacent over hypotenuse. Okay, so to get rid of the cosine now, since we're looking for the angle, we're going to use the inverse, so cosine inverse of cosine y. All right, and that's equal to the cosine inverse of 2.2 over 4.5. And so y, because these two undo each other, is going to give us, so trig cosine inverse 2 over 5.5, and we get, and we're going to the nearest degree, so 60.7 puts us at 61 degrees. All right, guys, that's it. There's your review. So tomorrow, some elevation and depression, and then we're going to do a little review and quiz on Tuesday. Partner quiz, people. Be ready.